All right. And I think with this we are live. So I kept a really interesting title, or at least as I thought about it, that the presentation is titled "Too Attractive to Repel," um, and like it's just a wordplay on attract versus repel, and just using some puns here. So one obligatory introductory slide about me. I'm a software engineer at Google Cloud India, and I work in the technical infrastructure side. This means that I get to deal with a lot of internal stuff at Google, and which I cannot really talk about. Previous to this, I was a applications engineer in analog devices India. I worked on hardware and embedded software for battery management systems for electric vehicles. So I like I cut across domains a lot. And if anything that qualifies me to give this talk is the fact that I used to use notebooks a lot for doing log analysis and plots during my time there in analog devices. And I've used notebooks even before that, but that was the most prominent time where I actually like got to use it a lot and realized how powerful this was. The other thing that binds me to the LLVM community is one of my Summer of Code mentees who now works at AMD, and he did a compiler based project for his Google Summer of Code. And he introduced me to this community. We have attended one meetup in January, like in March, I guess, the one at March at the previous campus of AMD. So my GSOC was in 2014 with beaglebot.org, and I continue to mentor for them until this year. And non-tech interests include music, books, and a little bit of dance these days. So how did this talk come about? And I took the liberty to post a small screenshot of the conversation from the WhatsApp group. So I was asked about like opinion on REPLs, and I said that it's good for prototyping. Like I posted something, and Aditya asked me if I would be interested to demo this at the LLVM meetup. And after that, I asked a question just to confirm my time commitments and make sure I have enough material to present to you all. And after doing all the due diligence, I realized that I can do this, and I definitely. And here we are. So the agenda for this is very brief. There is a tell and there is a show. So in the tell part, I'm going to like tell some uh, a brief introduction of what REPL means, and some concepts and early uses that you might find interesting or intriguing, and that might serve as something that you want to investigate further. I'll also talk a bit about IPython, Jupyter, and maybe Cling and Root, but I think those slides are not there, so I'll just skip over that. This point onwards, I guess I can see that this is all visible for you all. So we'll continue like this. All right?
Yeah.
Yeah. Yeah. So the agenda, this is what I talked about just now. We go to the next slide, which is what does REPL actually mean? So REPL, like if you just spell out the individual letters, read, eval, print, and loop. And in fact, this also describes how REPLs are actually implemented practically, because you usually have some kind of an interactive shell, and you use that interactive shell. um, you input something in an interactive shell that gets read. The programming language framework then like it just executes that, and then if there is any output of that, it gets printed, and then you loop. So you kind of get to the point where you wait for the next instruction. So this is an interactive way of doing programming, and this is usually developed over an already existing language or framework. Some popular REPLs are like, REPLs exist for Python, they exist for Ruby, for Node.js. Mostly, more commonly for interpreters uh, rather than compiled languages. Although Cling is an exception, and we are going to talk about it now. And REPL is also a different programming paradigm. And I say this because if you go to the origins of REPL, so here what you will end up seeing is that I have linked to two blog posts. One blog post is called Programming by Teaching versus Programming by Carpentry. And there is another blog post about the same concept. And it also talks about the fact that REPL originated from the time of Lisp. So early 1960s. And this, like, my references for this are, of course, Wikipedia and a little bit of Reddit as well, because there they said that like that's where it is. And REPLs can also be used for self-modifying programs. And there's also another interesting concept, something called as a break loop. So what does a break loop actually mean? Let's take a look. So what happens in a break loop is you like just like you call programming by teaching, you ask the program to drop into a shell at some point of the code that you haven't implemented. Like you have a structure for how you want to implement it, but you haven't really implemented it. So you drop into a shell at the exact point where that thing has to be implemented. Now this shell has all the scope and variables at the time when you dropped into the shell, as the rest of the program or the interactive stuff continues to execute. So imagine you have a graphical user interface, or like some kind of background process that's already running, but then the code that you want to execute is your foreground. And you have like, instead of kind of like continuously going in a loop, you have dropped into an interactive state where you can control the flow of the code. If you want, you can add new code, you can subtract the existing code, or you can also examine the state of the program, as I said, modify the behavior. And once you are satisfied with what you actually want to do, you resume, and then the program continues to execute with your new behavior. So let's say you change something in the loop, and uh, like after you returned, or you like returned out of the break loop, now whenever that portion of the program executes, your new loop will execute. And it's not that in order to write the code for the new loop, you had to terminate your program, and you had to rewrite the code. You had to perform several iterations, as you might have done had you been doing this in a form of a compiled thing, right? Like you compile a program, you execute it, something is not right, you terminate it, you change it, you recompile it. uh, and the difference between this and a breakpoint is that uh, like in a breakpoint, you can't really have the potential to modify the code. You can just interrupt it, or like you can't redirect that. So that's how it differs from a breakpoint or versus debugging. So this is an important thing to know about REPLs. So REPLs could fit in memory as less as 48 kilobytes. Interesting bit of trivia, but yes. And Lisp REPL was used in the NASA Deep Space Probe. Uh, and it turns out that when the probe was sent into space, they had a race condition in the program, and REPLs played a very important role in fixing it. Because imagine how would you do that if the firmware or the software for the probe would have been pre-compiled. You would have to recompile and either upload the entire program, or just kind of like try to imagine to do that or perform that tweak uh, online, like when your code is running, trying to fix when your code is running. So that's one interesting thing that I found about REPLs in my research for this talk. Um, so IPython and Jupyter, like Python by far is the most well-known REPL for now. You could think of your Bash shell as a REPL too. The concept is the same, even if it's a Bash shell or it's a Python shell. But the thing is, once you go from Python to IPython or you go to Jupyter, you add more layers of interactivity. As in, your Python code is going to execute the same way. But what will happen is the kind of power you have of tweaking the execution control of your program or doing stuff is going to increase a lot. And Jupyter is the organization that provides and maintains the underlying standards for notebooks. And notebooks is what has become popular these days in both the machine learning community as well as in other places also. So in data analysis communities also, because it provides like pandas, matplotlib, R, and Julia, Python, and R, right? So this was again one of the things pointed out on the WhatsApp group discussion when we were discussing REPLs. So that Jupyter, it stands for Julia, Python, and R, like the most common language it was designed for initially. But now Jupyter also supports Cling and C++ kernels. So that's also interesting, and we'll see that in the demo. Moving on, I think this is a copy of the previous slide because I couldn't populate it in time. So I'll just spend some time talking about Cling and Root before we go into the demo. So Cling originated from a project called as the C++ interpreter, or CINT. And so Cling is, I guess now it has been merged, or it's like a part of the LLVM project because it uses LLVM. The challenge with like C++ is that it's a compiled language and it's not an interpreted language. So trying to fit the same concepts that you would fit in an interpreted language into something that's actually compiled is is a tricky thing to do. And I guess that's where the knowledge and the expertise that you folks have on the LLVM side or on the compiler side is what would make a difference when you would use that knowledge to contribute to either the root framework that uses Cling a lot. The root framework is again a data analysis framework that CERN maintains, and it uses for its physics analysis. I have a couple of demos for that as well, which we'll go to now. Okay, so let's begin this. Let's begin this part. I will move some windows aside and I will open up my screen, which is the one. Okay, this one. Yeah, the layout got disturbed a bit, but we are back. Present something else. Now we have the entire screen, and let's present this one. Is all the content on my screen visible? Please let me know if I need to increase the font size somewhere.
Yeah, in the code and by.
Okay. Is it better? At
Yes.
least this side. I will also do the same over here.
Yeah,
Let's,
this is good.
yeah. This tab is not very relevant for us, but it's just that the notebook server is running over here. This is the relevant tab that we would actually like to use. So Uh, so let's try the first thing, which is the root prompt. So I'm going to start with okay. So instead of going with Cling, let's actually first start with a Python notebook. So for that, yeah, is the Python notebook visible, right?
Yes.
Yeah. Yeah, I just zoomed in one level more. Now what I'll do is I will clear outputs of all cells, and then I'll also restart the kernel. So the concept in these notebooks is that there is a kernel, and this kernel is what will be executing your code. And the other thing is this kernel also maintains the state. So as and when you execute these blocks, which are called cells, one by one, it maintains the internal state, like all the variables that you have defined, the packages that you have imported, and like whatever you are displaying. So there are a couple of things going on here. The other thing is a cell can either contain some Python code. For example, if I type print, that's a Python statement. But I can also use some markdown stuff in here. So I can write something like sample heading. This this is some markdown markdown test uh, list list two. And then when I run this, it uh, renders it in a formatted manner. From here, we can actually delete cells. We can reorder them. This is the general interface of how you would go about doing things in here. So let's start with the very first statement, that is importing all the necessary libraries that we need. So now you see that there's like a one written over here. So this means that this is the first statement that got executed. If I execute this over again, now this is two. So this allows you to see in what order you executed the statements. And if I change something here, now you see that the color has changed, which tells me that the contents has deviated from what I executed the last time. So I have to execute this again. I'm going to see an error again, but again, like I don't see that error because I imported it with a different name. So now what happens is NumPy is accessible both from the NP namespace, and it's also accessible from the NPS namespace. Note that even though I have changed the code back, the previous state still remains maintained, and it will stay maintained until I restart the kernel and lose all the previous states. So you cannot like unforget variables once you have like unremember variables once you have remembered them. Okay, moving on. I also have a sample CSV with some data that we can use to see some graphs. So now that we read this CSV, let's take a look what it has. You just write contents and it will show you the contents of that variable. So here we have a data frame and we have 4 columns and 100 rows. And this is some random data that I generated for the purpose of this talk. But again, now let's see if I wanted to see like these are the rows and these are the columns in the index. So if I wanted to see the 51st to the 53rd entries and all the columns, so I would execute this statement. So with this, now I can see that row 50 and 51 with a zero based index, of course. If I wanted to see 51 and 60, I can do that right here and I will have that. If I wanted just 2 columns out of it, or yeah, if I wanted just 2 columns out of it, so we'll do something like this. Or if I want just 1 column, it's going to be something like this here. Okay, maybe we have to give both a starting and an ending index. Yeah, I don't know why it is affecting, why this is affecting the one on the left hand side, but anyway, you get an idea. So let's move on. So if I wanted to get the age of the 95th person in this, so this one here, so I would run this statement and you can verify that output matches. Now let's write a small Python function, and this Python function takes the index of the row, and based on that it generates the name, so the first name and the last name concatenated it, and it returns you the result. So you do that, and there's no output because here you have just defined the function, you're not executing it. Here you're actually going to execute the function, and you can see how it outputs. Now let's say I want to flip the order of the name, so I just change the implementation of the function. So I changed the implementation of function, reran it, and then when I run this part again, I see that the name has updated, like the function has been changed. So, so you can see the power of having an interactive environment. If you were doing this in a compiled manner where you would have to like sequentially read the CSV all the time, then you would have to re-implement this function, and then you would have to, like, say you want to test it with multiple values. So for each of these various things, you'd have to change so many other things. And let's say you just wanted to like change the file that you want to read or examine. So you don't have to re-implement the function, and it's like if these functions are also expensive, or these operations are expensive, then you get the idea. Like you don't have to re-implement everything, and if and that's where REPLs help you, because you don't have to recompile the entire thing again and again. So if you can extract your stuff to something that is interactive and something that is non-interactive, you could also even, like, it's not even necessary that everything has to be in Python. You could implement some of these things in C to speed them up, and then call them interactively from Python, so that you get the advantages of both, which we'll come to later when we use root. So now let's look at matplotlib. So I just told this to do a histogram of the age. So you can see that, yeah, yeah, Raghav.
Yeah. So if you change something in the middle, like for example, you've a bit earlier on, you changed the order of the. Okay, but that was the printing order of the name, is it?
Correct.
But I mean, if you modified something earlier in the notebook
Hmm.
and then you use that modified item later on, would
Yes.
that does Jupyter like retroactively just rerun everything after the modification?
It will not do that. So for example, let's say you now change the CSV over here, and now you would have to re-execute everything that depends on that. So that's the disadvantage with this model, that if you change something before, now you have to go back and re-execute or realign everything to like reflect the new values. And this is a known thing, this is like working as intended. I read this somewhere, I don't have an exact citation, that the people who made this say that, if we could go back and fix this, this is one thing we would want to fix, that this retroactive re-evaluation kind of thing. And interestingly, if you read that article in my slide on programming as teaching versus prime by carpentry, you'll find that this is actually something that Lisp implements. So Lisp standard has an implementation that if you update a class, all the objects of that class will update with your new implementation. And you have to explicitly define what will happen, or like how you have to re-implement it, and that will then be used by Lisp to re-implement everything. So yes, yes, thanks for asking that. Yeah.
Abhishek, we are running out of time. If you can share the link, that will be nice.
Yeah. Okay.
Yeah.
So I'll just now go to maybe I'll just show the cling part now then. So actually root is the namespace that you just import. So in here, so these are functions from root, but they also have their corresponding C++ sections. So I think I'll just take a couple of more minutes and wind up the demo. So this is not matplotlib, but this is the root framework. And then here there's an example of importing C++ code from within Python and using it from within Python. So this C2Py example.h file is over here. As you can see, this class is defined. A stores a variable that you call the constructor from within Python. And then there's another function that you can call print A, which gets called here, and then it prints the value. And if I update this value to something else, you'll see that change reflected immediately. Uh, this redefinition is probably happening because I need to separate this out from the other two blocks. There is another tab which has the corresponding C++ demo for you. So the standard cout, the standard functions, everything what you did in Python, same thing is happening in C++, but we are now using Cling instead of Python. So you have a nice, like you have these graphing functions. You can define that. You can get a plot of that, and this is all interactive. So then after that, you can also pre-import C files as macros in here, and then you can see that the macro executes and it kind of gives you another graph. And all this material was taken from the root um, documentation. I will, whatever things are not a part of the slides, I'll share them later, but I guess this is all I have for the demo. I just have one more slide for the thank you. And this is my other website apart from the embeddedkitchen.net, which is technical. Kumadabhishek.me is more of a personal website for the non-tech side of things. Currently, you just have an about page, but there's also an option for a mailing list and more to come. Thank you everyone for the opportunity. Thank you, Aditya, for having me present this. And I look forward to interacting more with the LLVM community going forward.
Thank you, Abhishek. Yeah, it was a pretty good presentation. This is one of the thing that is slightly different from like traditional compiler. So I wanted everyone to have an idea that there is another world out there that uses compiler technology, but it's not like people do not immediately think about it. Pradeep, we
Yeah,
can resume with
yeah.
the
Sure. Did you have the slides?
but you have anything in the previous slide, or we can continue with the compiler
Oh, we
slides?
can continue with your slides. Yeah.
We,
Uh,
I think
y-
we have some questions right in the chat.
uh, I
There is one
okay,
question
okay.
by
Is it
Ashutosh
okay?
that
Okay,
Yeah.
yeah, yeah.
yes,
Raghav's question, I guess, is already answered.
yeah,
Ashutosh's question, I guess you just saw a demo of Kling right now. So it's definitely
Yeah.
possible for
Okay.
compiled languages. And there is actually a really interesting link of talks at the like in the root uh, project link. So there are 4 talks. I am going to paste the link right here in the Meet chat, and you can go through the slides. These are really interesting, and they talk about some of the intricacies that you would be more better like be able to understand. You can go through these 4 slides, and they should be able to answer everything. Yeah, and
yeah.
yeah,
Thank you. Thank you.
yeah. So one more question, like Mohit mentioned something like changing register values of memory mapped region, and debugger itself injects CC for adding breakpoints in memory. Yeah, something similar.
Yeah.
Yep. Yep. That's it.
Yeah, the interpreter kind of ties closely with how debuggers work, and it's pretty interesting. I mean, most people in C++ community they are not like they do not pay attention to that, but we are actually using it without even realizing it so much. But I guess when Kling has been ported to Jupyter, it's like kind of opened up avenue for a lot of programmers to try out C++ without even opening a text editor or something. So like reduces the barrier for like many people are scared of C++. So I hope they're
Yep.
not being
Yeah. Yeah. Yeah.
awesome. Awesome. All right then. Thank you, Abhishek. We'll start with the main the topic of the meetup was about compiler jobs. Okay. Of- so what we'll do is here's the setup. Like we have few slides to kick the session. We'll talk about in general like few things like what compiler engineers do, how their life is, and how to find jobs, etc. And then we'll have the LLVM social organizer will be kind of doing like a panel. So we'll have some cues to discuss, and at the same time you'll be able to ask questions in the middle. But first we'll go through very basic things. It is likely that 80% of what we are going to share here, but maybe 20% is also valuable. Yeah, so let's get started. The first thing about, oh man, yeah. So first thing, just to, anyone has a question? Yeah. Okay, yeah, you can continue in the chat about REPL, that's totally fine. So first things first, like what are compiler engineers? This is mostly for, I'm sure there are students here, so they might be like, what are compiler engineers? What do they even do? So very basic, and this may not be a very precise definition, but we are people who are like, we are designing, developing, and maintaining tools that uses compiler techniques. What are the things that uses compiler techniques? Of course, compilers, interpreters, VM, tool chains. And there are many other technologies which are related to analyzing, verifying software. There are other things that we do, but on a broader level, you should not only think that compiler engineers are only working on LLVM. There is like, I think 80% of compiler engineers are not working on LLVM. So there's a very big compiler engineering crowd. What do we mean by compilers? Like GCC, Clang, those are like native compilers. Microsoft Visual Studio has this. Interpreters, they are also kind of come in the compiler domain. JIT compiler, like Java C is there, and so Java runtime. They compile the code, they execute the code in real time, right? There are many other basically. REPL also falls in that domain if you think that way. Database query. It's very unlikely that people would know that database uses a lot of compiler technologies. Only when you take advanced database courses, you'll realize that first part of database courses are all this set theory and all this like complicated things. But later on, when you go to queries, it's all compiler technologies, and there is a whole lot of compiler technologies there. And recently, ML, I don't have to say anything, but there's a huge crowd of compiler engineers coming up because of ML. Typical responsibilities. This is a boring but very important slides. People who are looking for jobs and just trying to figure out what is out there. What are the typical responsibilities? First thing, what a compiler does is takes a language and translate to another language. At a very broad level, that is what compiler does. The other part is design and implementation. So you have to, let's say you're writing a new compiler, you have to define the architecture. For example, when LLVM was starting, Chris Latner had to think about how the compiler will look like. So he thought that it should be a set of reusable tools. So that was a design decision that was one of the most impactful things about LLVM, right? So this is very important. On a day-to-day basis, you are doing optimization. Like for example, I write compiler optimization. So Optimization may be related to executing code faster. It could be less memory, less code size, less power, depending on what your cost model is. Code generation, pretty obvious. Analysis and verification is about, for example, when you do static analyzer, or when you have sanitizer, or you have verification engine like theorem prover. Those are also similar typical responsibilities. You may not be working on a SAT solver, but inside the compiler also there are verification engines. Debugging and testing, of course, everyone has to do it. Maintenance and support. This is a large part of compiler job at many companies. Let's say when people who ship the tool chain, um, when you ship the tool chain, it's not like just you ship the tool chain and done and dusted. No, you have to support that tool chain for several years. Okay, and there might be bugs, so you have to fix that bug. I mean, you don't have to always fix the bugs, but you have to make a decision at least that should we fix it or just let it be there and fix it in the next tool chain release. So there is a lot of work there. Performance analysis. This is also one of the interesting part when we many compiler engineers work on workload that are very high value, business value. For example, I used to work on optimizing the launch time of application. So if you reduce the launch time by like, let's say 1 millisecond, it's a very big deal. But how do you analyze them? Compiler engineers have a very different way of thinking about programs. There are many other performance engineers, but compiler engineers are also very important. Research and development, pretty obvious. And the last one is about profiling technologies. Recently, if you are into LLVM, you might see there is PGO is getting a lot of improvements. Similarly, other compiler tools will enable like instrumentation or sampling technologies to improve, analyze the program so that we can find out the bottlenecks and do performance improvements. Where do compiler engineers work? Ashutosh, you want to take this slide?
Yeah. So there's a lot of places. One is obviously big tech companies where, as Aditya said, Google for Go, Apple for Shoes. One I'd say is that for hardware companies, right, one major thing is semiconductor companies, right? So any company that manufactures chips or has its own platform, they're going to have compilers for their own platform. So this includes AMD, Intel, Nvidia, Qualcomm, or smaller companies like Mipsology, or even houses that have FPGAs and all that. So hardware companies also have like very established compiler teams. Then there are research institutions. So in India, a few famous colleges where there are like really good compiler teams include IIT Madras's Space Lab. So that's pretty good. IIT Hyderabad has a very good lab. In IIT Delhi, there's Professor Saurabh Bansal. He's also working on compilers. There are also a couple of startups that are based out of universities with compiler labs. So one example of this is Polymage from Bangalore, which is Professor Uday Reddy's startup. It's based out of IISc. There's also Compiler AI from IIT Delhi. And there are also other research laboratories in USA. You have ANL, BNL, Brookhaven National Lab. They also have research institutions with compiler teams, and universities, of course. So you can do a PhD on compilers, you can do a master's on compilers, and universities contribute a lot of real cutting edge compiler research. So for a lot of places, like fields where people do a PhD, like, they often have a complaint that research is very different from industry. But I feel compilers is a very nice space where research and industry collaborate in a very good way. Even at AMD, we collaborate with several professors. So, it's really nice that they also build tools, or they build the next generation of projects. So, few people know this, but if you studied the history of LLVM, even LLVM was a PhD project. So, and so even MLIR was created with the support of researchers. So, these are all university projects. And then there are third-party vendors. So example of this include multi-coreware and compilatory and other such companies. So these support other companies, but if you join them, you're pretty much doing a compiler engineer's job. So yeah, compiler engineers work in a lot of places, and a lot of companies that don't even sell compilers as a product internally use compiler engineers. So yeah, that's pretty much it.
Yeah, thanks. Um, the next part, Sikar, yeah, you have a question? Go ahead.
Yeah, thanks for giving the platform. So I have this question. If I consider as writing LLVM or MLIR passes being considered as a developer job, as a like an analogous to developer job when it comes to the compiler engineer, then how much time a compiler engineer actually devote towards writing such passes in his or her job?
So this is a good question. So just like so you're asking for analogs to software, so I'll answer in the same way. So just like in web development, you have a front end and a back end, right? So in compiler teams too, there are engineers that work on the front end. So engineers working on the front end will typically be working with language constructs, compilation failures, or like implementing new pragmas and stuff. Whereas engineers in the back end will be working more on optimization passes and getting performance gains in benchmarks and optimizing for some various workloads. And then there are also engineers who are into performance analysis. So they are like looking at assembly dumps by various compilers and seeing that, okay, this compiler is using these many load store instructions, but we are using more load store instructions, or this compiler is generating a more vectorized or more optimum sequence of code, whereas we are producing a less optimum sequence of code. So there are some people that hack the IR and show that, okay, you can sort of produce a more optimized sequence of code for a given thing, and then tell that, this is an opportunity for, gains or uplift. So it really depends. Like compiler teams are internally quite big from the inside with different people supporting different functions. So the real answer to your question is you can spend as much time as you want depending on what role you want to do. If you don't want to do that, you can choose roles that are more front end or more analysis heavy. If you want to just write passes, you can choose roles where, the main job is finding optimizations and writing passes.
Yeah.
I
One,
hope that makes sense.
J-
Yeah.
Yeah, just sorry for interruption. Just one following question. Thanks for the answer.
Yeah.
With respect to the prospects, whatever job roles you just described, with respect to the future prospects, are all of
Yeah.
them equivalent, or some of them, have higher or larger future prospect when we, talk about growth and salary itself, basically?
I mean, see, so I'd say that most of the money is in optimizations. Like that's what a lot of people say. And if prospects are bad for something, I'd just say it's probably the testing and validation guys, but that's sort of true everywhere that manual testing and validation is being automated in various ways. But
Yeah.
otherwise, right, compiler engineering is always dealing with state of the art, right? Whenever a new piece of silicon comes out from AMD or Intel or NVIDIA or some other thing, or now you even have these heterogeneous computing, like on GPU side, there's still a lot of stuff that compilers can do that they haven't done yet because GPUs are somewhat newer paradigm compared to CPUs. And now we have hybrid accelerator cards, right? So all of this is like brand new stuff that is being created, and you have to write software for it to support that hardware, right? So there's also stuff where you study the interaction between the compiler and the kernel and stuff like that. So that way, I think you're always going to have space to grow. But as with other things, it's a research-heavy field where you have to constantly keep learning about newer things that come out. Like all of my colleagues in my company who started, none of them started working on LLVM, right? They started working on GCC or Open64 or some other platform, and now then they shifted to LLVM, and now several of them are learning MLIR. So you have to constantly keep learning and seeing what all new things are coming out, what new techniques are coming out. But yeah, there's always space to learn and grow, both in compilers and also horizontally. Like some of the seniors in my team, they know about compilers, they know about kernels, they know about GPU, they know about everything because they've explored it at different points in their career. So yeah, there's a lot of growth prospects. That's what I would say. It's a very stable job.
Yeah. Uh, so one more thing I would say, like you asked that which job has growth prospect. Like when you are like early engineer, right, or you're still in the college, you have a plan that okay, I mean, let's say you think that, or you are really a like super talented person, and you are like, I want to grow, and like reach at the top. But later in life, once you are in the job, you will have life that will happen. Okay, and not everyone is interested or motivated in rising to the top of the ladder. Everyone has their own priorities. Like some people look at job as a like they go, they do a lot of work, and they like to really accelerate, promote. But some people are like, they go to the job, they finish the job, and then come back, spend more time with family, friends, and like other things. So depending on so for the person who is looking at job only as a job, their cost model is different, right? They are probably not interested in rising at the top, so they want to be at a place which is a little bit stable. And some all the things that I have listed here, like the typical responsibilities, some of them do provide that. In fact, like for example, there is a bullet point like maintenance and support. Okay, there is a large pool of compiler engineers. You might, those jobs will be mentioned like tool chain engineers. So what they do is they ship the tool chain, and most of the time they are not writing a new pass. They're shipping the tool chain. So this is the end product. Okay, so there is a customer facing role here. Okay, but they do have to know about compilers. Like if a problem comes up, they like, who will fix them? Most of the time they are like pretty senior engineers. So engineers who are like, oh, I'm not interested in rising to the very top. I like this stable job, but I know about compilers, and I want to help end customer meet their goal. So like I can give you example. Let's say when you write iOS app, you have Xcode count the tool chain, right? People who are shipping the Xcode toolchain team, they are most likely not writing optimization passes. But if they are not there, then like millions of app developers will be in big trouble. So they are playing a very important role by serving their end users. Okay, that job tends to be fairly stable, but very, very important. Okay.
Just to add on to what
Mm,
Aditya said, so
Thanks
you
a lot.
might, yeah, yeah, you might think of like toolchain engineering as like somewhat non-glamorous, but it's a very interesting job in its own right. Like
yeah.
in AMD, at least we call them like field application engineers, and as Aditya said, they're very senior roles. So their job is mostly like presenting, our software and hardware to a new company. So these are folks that go to other companies or other universities that have potential tenders for like, we want to buy 100 servers or something, and we have this huge order, but your platform has to produce, your platform should be the fastest at compiling our application or running our thing that we run on our this thing. So then those guys have to essentially figure out how to run that software. And when software has a lot of parts, right, sometimes you might have the compiler itself breaking, other times you might have OpenMPI breaking, or some dependency might break, or it might even crash. And they sort of have to figure out where the problem is coming from. If there's a hot fix that, like, like turning off some flag or something that fixes the issue, they do that. Otherwise, they pass it on to the developers. So it's sort of like DevRel, but a far more technical kind of DevRel, and it's very interesting what they do. So yeah, that's it.
Yeah. So think of like looking at bottom up versus top down. So let's say when you're writing an optimization pass, you are like writing your one little thing. It may be very innovative, creative, and it can give you research papers, and maybe it can do a lot of good things. But it is one thing in a bigger uh, ecosystem or a tool chain, right? But for a tool chain engineer, they are looking from top down. So they have a thing called tool chain. and then you have to answer all the questions. So they have to have fairly good idea about almost everything. Like writing optimization pass is one part. It's like probably 10-20% of the entire compiler. There is a whole lot of things about like parsing, first part, front end, right, where they have to ask, like, does this compiler support this tool chain? Does this compiler support this language feature, like latest language feature as well as oldest language feature, right? Not everyone is interested in C++ 23. They might be like, where is my C++ 98 support? It's broken. I cannot use it because I have a code that written by people who have already died. So, but I want to run this because it gives me billions of dollars a year. And means I'm not making it up. These are real examples. Okay. There are code bases for which the source code is also gone, but that's a different story. But anyways, what we'll do is, there are questions on the side. So what I'll do is, like, first I'll go to the next slide and I'll ask Prerna to present this, and then we take the questions when in the panel. Go ahead, Prerna.
Okay, I hope I'm audible. So after all this discussion, you might be wondering where can you find all the job resources, or you may be knowing where you can find out. So typically, I have seen whenever the teams are hiring, either their managers or someone in their team really posts. They have LinkedIn posts, and you can see the jobs out there. And Indeed is another such platform. Uh, the second link, actually, this one is a very nice, I would say, a collection of the companies which are offering jobs in the compiler and related fields, like tool chains. Jobs related to tool chains can also be found here. So it's present in a nice alphabetical order, and you'll find hundred of companies which require compiler knowledge. Another way is by attending conferences. You either present there or you're a volunteer there, and all of these will help you connect to people, learn more about what are the various kind of jobs, and once you have made the connections, you will also get to know if there are any openings in their teams, and either in their teams in industry or maybe some research project. For example, um, IIT professors, they typically they offer guidance for BTech projects, or they even offer internships. So that's also one good uh, platform, I would say, if you are in India, based out of India. And Google Summer of Code is again well-known organization that pays you for contributing to open source projects like LLVM and GCC. And even if you are not actively participating in GSOC, you could be very much contribute to the open source code basis by fixing the bugs, or by if you have a new idea, you can either go to, let's say, LLVM discourse and uh, seek suggestions and get implemented if it gets approved. And yes, I was saying personal connections are um also very helpful in this if you want to land up a job in compiler.
Yeah. Pradeep, you have something to add to this?
Oh yeah, I mean, if you also attend meetups like this, you'll also get to know jobs in the field. I think every meetup we try to post jobs that are opening in companies that we know. So please join the meetups and learn more about it.
I just have a question. So,
Go ahead. Yes.
yeah. So, to what extent do we have to have projects regarding compilers? Because I just started compilers a few months back, and I've
So
probably done the Cornell University's CS 6120, and I've done till LLVM pass. But I've also done like quite a lot of LLVM. I mean, LLVM
yeah,
in the sense I've just analyzed LLVM code of some inferencing AI tool.
yeah. So this is a good question, but what I'd like to say is that one is that more than like the breadth, you really need to have a depth in a lot of stuff. Like
Correct.
obviously, having compiler-related projects is a good start, and it's really good. But often in half of the times when I take interviews, we ask questions from really basic C++. stuff like memory management or even how malloc works, or stuff on like stack versus heap, or what happens when you will this program compile or not, or some really basic stuff, and people fumble there. So first thing is like, yeah, obviously have really strong programming basics in C and C++ particularly, because most compiler companies hire from that sort of domain. But for projects, yeah, I think like one very, very short way of at least landing an interview is trying to push some patch, get some patches into LLVM. It's easier said than done, but like there are parts of LLVM that are much more nascent and developing compared to the main LLVM core itself. There are projects like LLVM Flang and even the incubator projects like Polygist or whatever, where a lot of work is being done and a lot of low level work is pending. Like LLVM Flang, for example, it supports only like OpenMPI 1.1. So the OpenMPI standard is something that's already pre-written all the way till 5.0 now, and you have various other compilers that support all the way till 5.0. So you have to just see what other compilers do, how they behave. You have a standard also, and you have examples, sample code also that should be supported. All you have to do is add support for that feature. There's also support for newer standards like F 2018 or whatever. So those kind of patches to a few patches to LLVM, or some folks also write toy languages. So if you have some kind of DSL or some other language that you're experimenting with in mind, you can write that. You can also do projects and stuff related to compilers that don't have to be exactly compilers. That includes a lot of other stuff. So, like playing around with kernels and all that. Basically, what we look for is some kinds of systems experience, because it mainly tells us that you're interested, right? One thing nobody wants is for a person to join a team, systems team, and then realize that they don't like this at all. So we look for some experience with that. So projects, open source are both great ways to get that kind of experience.
Yeah.
Got it. Got it.
Yeah.
Yeah. Thank
And
you. Thank
like
I
you.
on a
think
behavioral side, yeah, Pradeep, go ahead. I'll
Yeah,
follow.
I think I'll add to what Ashutosh said. So most people who come into compilers, they learn compiler technology, but they don't understand what the things that surround them, right? Like systems, especially like how the hardware works, how the runtime works, etc. And they get sort of puzzled, and it's a vast field, and it's hard to understand just by knowing compilers. So you'll have to know things around compilers to probably contribute to that. Yeah.
Yeah. Just to add on a like a as a on a behavioral side, maybe you are still working on compilers, but maybe you are not. But and wondering like should I work on compilers? So one thing that helps a lot is you have to have a lot of patience. Okay. And you have to have a knack of for fundamental things like fundamental algorithms, how things work under the hood. And most of the time in the compiler team, you are not in a hurry. So because the problem that you might be dealing with is pretty good, is most likely it's like pretty deep problem. Because if the problem has been fixed, nobody's in one worried about that. It has been fixed, it has been automated. Compiler is like a very big automation engine. So once it is done, that part is mostly done unless something really weird happens. So having a patience, why I'm saying this, because when you are going early in your career, it's extremely unlikely that people will say, oh, you came here, now you write an optimization pass because you are the cooler, you are the like smartest person in the team. No, it's very unlikely. What will happen is you in the beginning you will be fixing bugs. Why? Because that is how you learn depth. Ashutosh mentioned, right? You need to have at least a lot of depth in at least one part. So you'll be assigned, let's say you are assigned a bug, let's say about a miscompilation. Miscompilation means that compiler is not producing a code that it was expected to, and it happens. Most people think that compilers are always like bug free, whatever, but bugs happen in every software. Let's say you have a code which adds two numbers and the output does not print the sum of two numbers. And you might be thinking, wow, this is a very basic problem, but it is a very bad real problem. It happens even now. Just all I have to do is tell you that these numbers may be floating point numbers, right? And then there's a whole lot of research, PhD, just to figuring out like what should be the output. Like there
Yeah.
is many cases there is no correct answer also. Okay, so these are real hard problems, and you'll be like, oh, this is just a summation, and then you have to read 20 papers to figure out what is the final answer. Okay, so having patience helps, because if you get frustrated, you will lose all your mental state, and then you have to restart. Sometimes you have to spend a couple of hours just to get into the state of reasoning about that problem. Okay, think of like a machine. When you restart, things load into RAM, right? And then if you shut down the computer, you have to reload that thing, and it happens more in compilers probably than in other places. So having patience will help you a whole lot. And because when you do the fixes are most likely smaller, like few lines of code, but then it will kind of alleviate a lot of problems for everyone else. So the reward is very, very high. Okay. Should we go through the questions in the chat? There's like few questions from, let me start from the beginning. There was, let's see, there is a question about, what is that thing?
There's a question on polyhedral model.
Yeah, is polyhedral compilation a growing field? In a similar way, are there people dedicated to reduce? Okay, so let's do the first one. Is polyhedral compilation a growing field? It's a. I would like blatantly, I would say yes. It is. But when I say polyhedral compilation, that does not mean LLVM poly only. Polyhedral compilation as a technology is growing because of MLIR, like machine learning space, because the whole lot of computation involves matrices, and when you operate on matrices, like multi-dimensional thing. So having a very sound framework is pretty useful. And I'm not the best authority here. I wish Professor Uday would be here. They have this startup called Polyblocks, and the name itself says poly, so you would know. I have not looked at their source code. I don't think it is open source, but they use from what I can understand, they use a lot of polyhedral technologies. And if you follow them on Twitter or LinkedIn and you see their numbers, it's just mind-blowing. It blows away anything out there by a big margin. Okay, and the whole thing is automatic because of they use polyhedral compiler technologies. Another thing is polyhedral compiler technologies is not only related to compilers. In the RTL design or hardware synthesis, polyhedral technologies has been used for a long time. There is a professor from, I think, Louisiana somewhere. He's an Indian professor. He's from India originally. I forgot his name, but he presents at the HiPeak. You see HiPeak is there, right, in the list of conferences in the slide. In HiPeak, there is a track for polyhedral toolchain, polyhedral compiler technologies, and he has been presenting there for a very long time. He works on hardware synthesis related things. So polyhedral, it's a technique. It's a way of thinking. So it has its place. However, mainstream compiler people, they most of the time they do not know about polyhedral, so they may not appreciate. So if you are trying to introduce your polyhedral thing into an existing framework, you have to be prepared to take it to the end. So you have to convince people, then you have to write this and prove it that it is working, and then you have to go to the last mile. Having MLIR, a fine framework, is helping for sure, because now it is slightly easier to convince than before.
Yeah, but one thing I'd want from a jobs perspective is that, like, a polyhedral is like, I mean, at least if you're starting out, it's a very, very, like, narrow thing to start out with. Like, make sure you have the requisite background before jumping into stuff like that. Like, it's like just knowing the basics properly before jumping into harder concepts is kind of important, because if somebody sees polyhedral on your resume, they're going to ask a lot of basic questions, and you'd better be prepared to answer them. So that's there.
Yeah. The second question is about,
Aditya,
yeah.
I think there are a few folks in the chat as well who are from the compiler WhatsApp group. I think Professor Saurabh Bansal is here. There's
Professor Saurabh is
Rahul.
here.
Yeah.
Yeah, I would invite Professor Saurabh to talk about polyhedral, because he has taken a class. I remember he used to have a class on compilers, and polyhedral was introduced in one of the classes.
Thank you for the invitation. I was happy to listen and learn. I don't have much to add. Actually, I was more interested in the industry perspective on, where polyhedral is headed. Yeah, I really don't have. I don't really have much to say, I guess, on that.
Okay.
But yeah, thanks for the session. I mean, I'm enjoying it, so that's all. Yeah.
Okay. Because now you are here, I would, if you want to talk about compiler labs, like what are you doing and what do you think is the future of
Sure. Thank you. So yes, I mean, one of the things that you pointed out was how compilers have miscompilation bugs, and this is, this is a real problem because compilers have been growing in complexity over the decades. For example, GCC adds roughly 750,000 lines of code every year, and it's been adding this amount of code since for the last 30 years. LLVM has a similar rate of growth of complexity, and a lot of this is in the optimization and code generation logic. So if you consider safety critical applications like the types found in aerospace, defense, or automotive sectors, then you need very high levels of safety assurance, and it is not usually acceptable to just use an off-the-shelf compiler like we are used to doing for our regular applications. So we are basically doing formal verification of a compiler's output. This space is also called translation validation. It mathematically proves that the output of a compiler, or the output of an optimizing compiler, which is executable code, is equivalent to the input to the compiler, which is the source code. And this is this is something that we've been doing as part of our research for the past many years, and we have made some progress, and so we are working to commercialize that work. Yeah, it involves a lot of it requires both knowledge of formal verification a little bit, and compilers a little bit, and it kind of also requires like an end-to-end view of what a compiler is doing, because a lot of things that we need to write algorithms to automatically validate, basically expose what a compiler is actually doing and things like that in an end-to-end way. So that's the nature of the work we are doing. We are definitely looking for folks to join us, people who have prior experience in ideally both formal verification and compilers. But if not, but I mean, if you don't have expertise in both areas, that's also okay. Yeah, we are definitely looking. So please write to me if you are interested. Thank you so much for giving me this opportunity to speak.
Thank you, Professor. It's an honor. We are very excited to have you here. I did not realize that you're here. But Pradeep, you're mentioning someone else.
There is also Rahul and Sanjay from
Prashant.
Qualcomm. Yeah, Prashant from AMD/Node AI. There are a bunch of folks in the chat.
Okay.
Yeah, I think hearing from Prashant would be interesting because he works in the intersection of AI, ML, and compilers. So, for a lot of folks here who wonder how machine learning and compilers work together, he'd have something interesting to say.
Prashant, please.
Yeah, so I think currently I don't have something interesting, as in, but yeah, we are working in code generation. We are working on code generation for CPUs and GPUs, mainly AMD CPUs and GPUs, optimizing ML models like large language models and stable diffusion mostly, but and So we are trying to see where CPUs and GPUs diverge. I mean, how can we leverage the compiler techniques such that most of the passes are same, and when they have to diverge, they have to diverge. So yeah, so it is mostly based out of that, and we target CPUs, GPUs via the single compiler. So
Interesting.
And I believe we also are hiring.
yeah, we are hiring. I was about to post that in the chat, so yeah, I'll post it over here. Send it to you.
Okay, thank you.
Nice, nice.
And we
Let's
also have Rahul and Sanjay
Rahul.
from Qualcomm. I think Sanjay is working on the ML compiler pipeline, and Rahul is working on CPU midland. So if you guys can also talk about it, that'll be great.
Yeah. So uh, at least at BDC, we work on multiple fronts. Uh, as I think Aditya and Ashutosh were rightly talking about, there are system aspects and then there are compiler aspects. And especially in the area of ML compilers, uh, there are a lot of system activities, I would say, like compression, how to solve the DDR bandwidth limited problems, right? On a couple of accelerators at least. And so most of our bandwidth at least goes on that. And some of the problems are very model specific. And yeah, at least I have seen most of them are, architecture specific as well, right? And those actually bring different set of challenges, right? And those challenges increase a lot when you're trying to also auto generate the code. Like sometimes people write a handwritten kernel, and some of them do also write what do you call some of them also try to auto generate the code, right? And at least in India, at least in BDC office, we have multiple roles, both in research, then in MLIR, and then also in Glow, right? And in case folks are interested, do reach out, and we can plan out something.
Awesome.
Just out of curiosity, the custom kernels that you're talking about, is that in context of PyTorch or CUDA or something else?
Good question. So, I'm not sure whether you're aware, Qualcomm has its own cloud solution, right? And not only cloud, you guys might have recently seen the Snapdragon XL8 announcements as well, right?
Yeah,
So yeah, you guys, I mean, hope in case folks are following the news, right? So I think the problems are two levels. Sometimes what happens is like generating optimized solution, optimized kernel code even to 80% of the handwritten code is also very difficult, as you can see multiple work front that Professor Uday also is doing, right, in this area. It becomes a bit difficult. So at least our initial approach has been that we write a handwritten optimized kernel, right? And we do spend a lot of time, which are operators which are representable in PyTorch, or also at least broken down into a different form of, let's say, Onyx or whatnot, right? And we do write specific kernels which are tailored to those, and also write, optimization passes on basically on the top of it. And most of that you work at least in the EOT domain happens in the, at least from the Glow compiler or, our internal IR as well. But when it comes to MLIR, of course, we try to leverage a lot of open source, right? And we do adopt those techniques as well, both in mobile and cloud, right? And again,
okay.
they will be very likely be really tailored towards, as of today, they are very tailored towards what do you call PyTorch, right?
I see. Yeah. Okay.
Right. Along with that, I forgot to mention, we also have a ML framework team. What they do is that their responsibility is end to end. Are not only compilers, they also are people who are responsible for enabling, a backend to PyTorch, or a TensorFlow as such, right? So those are a different set of roles as well that we offer, right? And of course, we have a variety of roles subject to a personal skill set. We also, do tailor them, saying that this is where your skill sets match, and then probably you can adapt to it. Yeah.
I see. So if I understand correctly, right now, does Xelite can execute like any random model on PyTorch, or you would have to convert it into a specific format in order to get it executed?
Good question. So what we do is, if you're not sure whether you're following, there is a Qualcomm AI model zoo, right?
Okay,
So it is just a reference for folks to, see, I mean, basically see what all kind of models have been onboarded, right?
I
And
see.
that is what been used for most of the Snapdragon X8 kind of benchmarking. But when it comes to cloud, we have recently released, actually open source the tools as well, where we basically show how we transform the PyTorch model into our. I mean, we majorly support Onyx, I would say. Of course, we support other
Okay,
IRs as well, but the major of the operator set is more tailored towards Onyx, right?
got it.
Mostly from a business reason point of view, nothing else. So yes, I mean, again, I mean, just to make developer friendly kind of deployment, we do support, we do open source those tools as well, right? And that helps a lot of our customers who cannot share their private models with us, and but it can give a kind of idea to them, what kind of passes one has to write, at least at the front end level, to make the model deployable.
Awesome.
Again, just a last point. That doesn't mean that, assuming that we basically add a backend itself to PyTorch, right, which is ongoing work activities, right? That will help us, a lot of people just to deploy the model in PyTorch through PyTorch, right? So
Yeah,
all those unnecessary tools can be avoided.
yeah. Thank you so much for sharing.
Yeah, no problem. Welcome.
Um, I think we have Rahul as well from Qualcomm. I think he's working on the CPU code gen. Rahul, if
Yeah,
you're
I
there.
was quite surprised to find another Qualcomm person, but then I realized my surprise was because he works at Bangalore and I work at Hyderabad. Hey Sanjay, nice to meet you like this.
Hey, Rahul.
Yeah. So, so like I said, I work at Qualcomm Hyderabad with the CPU compiler team. There are a bunch of like other compiler teams which other than the ones that you just heard of, like mine and Sanjay's. But so active, my team at least is actively looking to hire right now, like mostly freshers, like 0 to 2 year, like either they're coming right out of college or like with 2 or 3 years of experience or something like that. We can work that out. But like if you're looking for a opportunity, please do reach out to me or uh, Pradeep. He can connect you to me if you know him. So um, and the kind of work that we do is like very different from what Sanjay just explained, because like we work on the CPU side of things, and we mostly work on the ARM and the RISC-V backends. So like a there is a renewed interest on RISC-V at Qualcomm right now, and like we're very actively working on that. So and also like uh, there was a question about polyhedral compilation. So there are parts of my team which work on the LLVM poly, which is like a dead project kinda right now, but we are trying to revive it to some extent. But yeah, and also there are like we have interactions with research people who are like working on research inside Qualcomm about polyhedral compilations. So yeah, it is actually like the people before us said, like it's a mix of a lot of things, as with any compiler job. So if you're looking for one and there is one waiting for you, so please do reach out. And thanks, Aditya, Ashutosh, Pradeep, all of you guys for organizing this. I was like initially skeptical because I thought like there was a similar session just like 6 or 8 months ago, and I was like, wouldn't it be the same people attending? And then I realized people are just here again with like new questions, and there are always going to be college freshers that are looking for a job. So this is a great idea to keep doing it at periodic intervals. Great job, guys.
Yeah, we plan to do like once in a while, something like
Hmm.
this, because not, there is only 50 people here, like, and 50 is, I mean, I'm sure there are thousands of software
Correct.
engineers coming up, so they might be interested. So awesome. Pradeep, you wanted to call out someone else as well?
I
Pradeep, I
have,
see Vimal
uh,
Patel. Is it the same person? Is it Vimal
I
Patel?
am not sure.
I'm not sure.
Uh, but just one more thing. If Rahul and Sanjay can share your contacts in the chat, that'll be help people for that'll be helpful for people to reach out.
Yes, I was
Yeah,
gonna do that. Yeah.
cool. Uh, you mean Vimal from Polymage?
From Polymage, I think. Yeah, I mean, I
Okay.
don't know. It might just be a person with the same name, but
Uh,
Vimal,
Okay.
yeah.
Hello, am I audible?
Yeah, we can hear
Yes,
you.
yes.
Yes, I work at Polymis Labs.
yeah.
Yeah.
Okay, Vimal, that
Yes, I can. Yes, I can. Thank you for calling me out. I can tell you a bit about our work at Polymis Labs.
Yeah,
Okay,
please do.
so as I think it is already, I think, known that we work on the uh, basically we are developing the polyblocks and basically code generator for ML models. Excuse me for a second, just a second. Yes. So basically, currently we support PyTorch, TensorFlow, and different front ends, and we aim to like front end agnostic. And yes, we do use like lots of polyhedral technology. And any question in that aspect, I can answer if I am familiar with. If you want to know more about polyglot.
Awesome. While you are here, I would like to know your thoughts on like how is polyhedral compiler technology going? Like, do you see more future, more avenues of polyhedral technology in other places? Or
Right, right. Okay, so uh, that specific question I would not be able to answer, I think. But I see that in particularly in ML model compilation area, right? There we see that we benefit a lot from polyhedral compilation. As like many of the transformations that we implement, uh, yes, there we do like we use more like significant amount of affine transformations and dependence analysis and all. And some of the transformations where we think that without this thing, I think we would not be able to do these powerful transformations and analysis. So there, yes, that technology is very helpful. Yes, that area particularly in ML models. I don't have any experience outside of this ML model compilation or compiler area outside of ML model compilation. So maybe I would not be able to answer that.
yeah, thanks for your answer for sure.
Yes.
Before we jump, we have a few questions in the chat, right? So I'll take one question and then we move to the question and like follow up. So there was a question about, are there people dedicated to reduce compile time? Because I think this is an important one. Yes, there are people who are, so what they want is, even if we have accepted that whatever compile time currently is, we do not want to regress it by too much. So if you are writing an optimization pass or something, then especially for the bigger companies, they do not want to regress on compile time because they are compiling code bases like millions of times per day. So even compiler itself become a performance issue for bigger companies. This is mostly true for big companies like, for example, like Google, Facebook, Apple. Yeah, otherwise, outside of them, not mostly you will not be worried about compile time. But there is a nuance here. If you are thinking about, let's say, JIT compiler or something, then of course compile time becomes important because compile time is also kind of runtime. So there you do not want to regress. Even there is a very tight control on what you can do, and that's why most of the JIT compiler will have very trivial optimization. They will not have they will not do like DFS or something. They'll mostly work on like basic block, like doing micro optimization for the most part. So yeah, let's go to. I think there was someone who was raising hands.
Yeah, sorry for the interruption. I had just one question for Vimal, as he works at the Polynesia. So, Vimal, whenever you are trying to achieve some loop transformation, so
Okay.
how much, it's a generic question, how much polyhedral compilation theory is required in your day-to-day job, or is it like there are ready-made academic tools or registry tools to, per se, Pluto, which is written by the Uday
Okay.
itself? So, how much in-depth polyhedral compilation theory one should know in order
Okay.
to basically work in Polymer?
Okay. Okay. So, right. So I'm assuming that you are we use MLIR. You plan to use MLIR for this loop transformation. Okay.
Yeah, tech stack could be, yeah, MLR, yeah, it's fine.
Okay. Okay. So if in MLR, if you want to do any loop transformation based on some affine analysis, right? It depends on from I think transformation to transformation. But now I think. For instance, let's say you want to do some unrolling, right? So there are already some utilities implemented. So it would not take a more implementation wise you are asking, right? How much implementation effort it would require, right? So
Yeah, yeah, exactly.
yes, I think it would be it would be very specific to transformations. But for instance, and for unrolling, if there are utilities already implemented, maybe you would need to tweak them or if it is not there, then it would require maybe few weeks or maybe yes to go through the review and all, maybe a month.
Just one following question. So you just talked about loop unrolling. So it's an
Okay.
open question. It's still like what should be the unroll factor? Uh,
Yes. Yes.
so how do you decide? Let's say if this is the problem that you need to decide the unroll factor. How do you go ahead with this problem?
Okay. Okay. So basically, how do you decide by which factor you want to enroll? Is it so?
Yeah, yeah, yeah.
Right. I think that would depend on what kind of optimization or where you want to apply this transformation, right? And also it would depend on what problem you are trying to, what optimization problem you are trying to solve, and also on hardware, I think. Yes, on that, the unrolling factor depends.
Okay, I
Yeah,
understand. Thanks a
enrolling
lot.
very depends on a lot of factors, and people use auto tuners to find out the best thing for their solution. So I think, I think
Yes,
enrolling really depends on the situation.
yes, yes. Okay, thank you.
Awesome. Um, Before we run out of time, I guess I'm sure we have more questions. One thing I want to address here, which is very important, is like many, like for example, women, they are like, how are there opportunities for them in the compiler field? Because if you see, the ratio is very, very skewed. It's probably less than 5%, if I'm not wrong. So if you are anyone, like I would invite like Prerna to talk about it, like our experience, like are there opportunities for them? How does the work environment feels like? And are there people promoting them, or what are the open source venues where they can get more help?
Thanks for inviting me. Yeah, I think there are opportunities. If you are passionate about the subject, there are opportunities. So I would take a recent example. There's a summer school going on compiler design and construction, which this time it has been only for women. So tell about summer schools a lot. You would be seeing because my journey started with the summer schools. So all my theory I have learned from the summer schools, I would say. And I got opportunities to interact with professors and they were from IITs and IISCs, and they were very approachable. In fact, I also got a chance to do my BTech major project under Kherkar sir. So um, if I'm learning the concepts, there are ample opportunities to apply them. So after that, I also got a chance to intern with NVIDIA, and after that, I became a full-time employee. So in our team itself, we actually work at the in the like complete backend. So which means that we convert the middle level IR, mid-level IR into the hardware level language. So uh, our team deals with a lot of compiler optimizations, and we write passes. We also have to care about register allocation, or let's say GPU specific optimizations. And yes, the ratio is skewed not only in compilers but everywhere. But I think it has mostly compilers. I would say it is more skewed because there is not enough, I would say, uh, not many people know that these kind of jobs also exist, these kind of system level jobs exist. So opportunities are there, and in our team itself, I would say there are around like 4 to 5 women, like just in my team. And the compiler org is quite big at NVIDIA. There also we have more women. So I would say there is a lot of opportunities if you are considering to pursue this field. And I always love this field, so I am here for like around 4.5 years, and I plan to continue many more years in the field. So that's what I would like to say.
Thanks. Thanks for sharing your experience. Let's follow up with other questions. If anyone has more questions? And by the way, there is a in LLVM Dev conference, there is a specific dedicated track for women in compilers. I forgot the link, but it's pretty easy to find. Yeah, outreachy. This one, Pradeep already shared this, but I'll copy paste again in case people forgot. So you want to go here, and there's this is for other like people of diversity also, but you want to have if you are interested and if you are curious and you have like no one to reach out to, like maybe you're not comfortable asking here, so you go to outreachy, and there's people, very friendly people who will just help you out. There is a question by Mohit. Are there any online summer schools available for those who cannot show up in person? Anyone has an answer? I don't know, but if anyone has a better answer here.
Summer schools do keep on happening. However, it depends on how you can find out about them. So it's not that they don't keep on happening, but you'll have to figure out where they happen. Sometimes they may be free, sometimes they may be paid. Uh, I did take one summer school in the past, but that was related to asynchronous digital logic, which is again an interesting topic in itself, not related to compilers, but yeah.
Yeah.
I think most of them happen offline.
In person, yes.
Yeah, in person. I think during COVID, there was one instance where the ACM summer school on compilers happened online, but I think nowadays it's mostly offline because you want to actually interact with the professors and do the work while you know while the lectures happen. So I think yeah, most of them happen offline.
Yeah, I would say offline, online, like LLVM Meet social, what we are doing is one way of doing. It's kind of, if you follow all of them, you'll have a pretty decent. But there's YouTube videos we always post there. So we have classes from like very beginners. We did the last year we did a track for introduction to compiler tools. It was like weekly for 10 straight weeks, and there were plenty of attendees, and you can go on YouTube and watch those videos. It covers like a lot of basic things as well, so you'll have, I hope you'll get more motivated after watching those. Bhash, you have a question?
Yes, am I audible?
Yeah.
Yeah, my question is more along the lines of what is the interview process like for freshers, let's say if they are trying for an interview, like Ashutosh was talking about C++ knowledge and knowledge for basically systems level stuff. So what else would be things that one should be comfortable with and know about so that they can work at the job they applied for? Thank you.
I'll give you a small answer, and then others can follow. So what we look for is, apart from like basic knowledge of like languages, like some of that questions, like how, let's say, how virtual function is implemented, or how operator overloading is implemented, like mem copy, mem set, memory. These are like typical ones. The thing is, even if I tell you this, and let's say you learn all of this, and in the interview we ask this question, and if you answer this question, what actually happened is you learned something very important. So this is not like, for example, comparing this with the traditional like lead code style question. If you implement into algorithms, maybe I don't know how much value they added to your skill set. But this one is, like when you learn, let's say, how virtual function is implemented or how mem copy is implemented, you learn something that will last for a very long time with you. So in general, it is good to know all those fundamentals, and we look for fundamentals. Of like, there will be a question. It's a very hard question, but I'll tell you how to debug a miscompile. I will not tell you the answer, but if you go and search like how to debug miscompilation, you will learn a whole lot of things. And let's say someone asks you this question, and if you answer them, they'll be very, very impressed, because very few people know about this. So things like this are like very fundamental graph algorithms, let's say depth first, breadth first, those things, because that is what we do on a daily basis. Like if I go on an interview and ask depth first search, like probably 90% will fail, but most compiler engineers will just can write a depth first search while they are sleeping. So like what kind of at least the algorithmic depth of compiler engineers is pretty high compared to other class of engineers. Anyone else have something to add to?
Yeah, I think regarding the job itself, it depends on the role. So I joined as an OpenCL compiler engineer, and most of my questions were related to the OpenCL language, GPU architecture, and compile optimizations and stuff like that. So, so the job, the interview itself depends on the job that you're applying to. But for most cases, you'll definitely need C++ programming language as a requirement, and some amount of computer architecture slash the runtime, the operating system concept. So yeah, I think that should be the minimum low bound.
Yeah. Awesome.
Yeah, actually, I definitely agree with what Aditya and Pradeep said. Very basic things are required, actually. Like, at least, again, depends on job, I would say, but some bare minimum things are like operating system related aspects, C++. In fact, that matter, even knowing 8086 also sometimes helps. Sometimes in case you're working with the hardware company, right? One basic embedded knowledge helps a lot, because that helps how one is able to map the program to a very basic kind of hardware architecture as well, right? And then of course, then there comes basic LLVM, and in case someone wants to go in AI compiler, so I know for that matter, even know about MLIR, that also helps a lot. Again, these are job specific kind of requirements, I would say, but for entry level engineer, bare minimum things are definitely expected, like knowing bare minimum graph algorithms and whatnot.
Yeah, totally. I mean, everything about compilers is based on graphs. You name it, we have all sort of graphs inside compilers. So yeah, definitely graph theory is an important subject you want to master.
Yep. Akshay has a question that like he's looking for internship, for example, in the United States. If you have 2 years of experience, how do you find like internship opportunities? So I don't know if you are studying, because internships are available only for people who are currently pursuing something, a course, not for full time. So you are doing masters. So yes. So if you're doing masters, and if you're, let's say, you're working on some research project, then most likely your professor, like compiler community is small, so everyone kind of knows everyone. So I would say ask your professor or someone in your department that if they have some connection, then they can suggest people to like take your interview at least. So that is like one path of like kind of least resistance, I would say.
Actually, sometimes what people also do is they do apply for internship, at least in companies as well, right?
Yeah.
Only universities alone, right? And I think at least companies like Qualcomm do honor in case there's a very immediate need. And of course, they're subject to whether people want to work from US or at least do the internship online. Those are subject to the requirement, I would say.
Yeah. Oh, so now I see Akshay is already in US, right? Syracuse University. Is it in US, right? Yeah. Oh, so you are already in US. Then I was thinking that you're in India and you want to do internship. That if you are here already, then it's pretty. Then there is just ton of opportunities. Um, just I mean, every big company has internship for compiler engineers. So. However, like most big companies, like let's say Google or Facebook or Apple, they might write their job description as just internship, software engineering internship. So it may not look like compiler engineer, but but Qualcomm definitely, like Qualcomm, Samsung. Maybe just ping me and I'll tell you more companies. There's compiler jobs GitHub page. There's you can also find there. But off the top of my head, Qualcomm, AMD, Samsung, they always look for interns, compiler interns, and in fact, they have a hard time finding them. Like many times, I used to work at Qualcomm, and they would have budget for like 3 interns, and they'll get one because they did not find enough compiler people. Okay, that always happens, and
yeah. I think Akshay, you're too late. I think just in case you want any still you're looking out for, do reach out, and
yeah,
I can see what I can do.
yeah, nice.
Yeah.
Wow, there is someone raised their hand. Please go ahead.
Yeah, sorry, may I speak?
Yes, go ahead, channel.
Yeah, I'm also in US currently, and I had given an interview for a startup based in California. The role was on a machine learning compilers, working on LLVM IR to optimize operations of neural networks, and etc. Um, but I was rejected after the fourth round, only because I did not have experience to show on LLVM. Uh, I obviously did prepare for my interviews. I did well, but I think what I lacked was some projects on LLVM stack. Could you recommend any source from where I can understand how to build these projects? Because I'm really unaware of how all this works.
So I guess one thing would be we had like last year we had a 10-part series on introduction to compilers. So that is one way. There is one video where you can see like how to get started with LLVM, and there are other LLVM documents. I can, if you can ping me, I can still point you to like the exact links. But the thing is, it's there is one this getting started. Let me just give you right now. LLVM getting started. So are you looking for project or you have like no background in LLVM? That's
No, I have. I did the 6120 course as someone mentioned, and that's why I
yeah,
know Cornell universities. I
yeah.
also studied compilers fairly well. The knowledge is there, but the implementation is what I'm lacking, and that's what I'm trying to
So
build
you want to do
before
some
I apply.
projects on LLVM, right? Okay.
Yeah,
Um,
yeah.
so um, let's see. There are two ways, right? One is you can work on projects that has been done by the on courses that are taught at universities. For example, North Carolina University has a course on LLVM. And if you go to the GitHub profile of any student at North Carolina, they would have that project. So it has very basic, like getting started with LLVM, then like implementing some basic like some people optimization, common sub expression, copy propagation, etc. So if you have like very limited LLVM experience, that is one way to start. But let's say you know a little bit more about LLVM, you are very comfortable copy propagation, etc., and you want to do something like more real, like let's say contributing to LLVM open source, then a straightforward way is to go to LLVM project issues, and then there is just, it has thousands of pending issues, so it's pretty easy there. If you are looking for very specifically for optimization, then you can reach out to me directly. I work on compiler optimization, and I have more ideas than I have time. So essentially, I mean, I will give you one example. Recently, I don't know if Vaibhav is here, but in the WhatsApp, I posted that we can do a comparative analysis of vectorization on LLVM versus GCC. Vaibhav is here, yes. I'll give you just 1 second. So we figured out that the STD reverse, which is a fundamental C++ algorithm, is not getting vectorized in LLVM, but in GCC. So, I mean, can you believe, like, we found a very fundamental algorithm that is not getting vectorized, and we created the issue we talked about in the vectorizer group, and this guy, Vaibhav, he just implemented that thing overnight. I'm like pleasantly surprised, and I'm like really happy that it happened, and his patch is up for review. I would ask Vaibhav to talk about it, his experience, and how is he feeling about it. So
hi, I'm Vaibhav. Is my voice coming clearly?
Yeah, we can hear you.
Yeah.
Yeah, I mean, I think Aditya is overhyping it, but I mean, the bug was not so big, and well, in the past, actually, the well, the problem was with scalar evolution. There's a past in LLVM called scalar evolution, and I've worked on it in the past, and I attended a meetup by Aditya, and he said that, and also you wanted to check the capabilities of LLVM in auto vectorization capabilities of LLVM, and I attended it, and he said that stud reverse is not, it's not auto vectorizing. So I looked at the scalar evolution code, and actually it was a very simple bug. Well, and they could have already solved this bug during the implementation when they implemented scalar evolution, but I mean they did not write the specific code for it. And it was very interesting, very interesting to know how the loop vectorization works and what is how the LLVM internal works. It was quite, because I'm quite new to LLVM as well.
So yeah, cool. Thanks, Vaibhav.
Yeah, I
Let's
think we are
see.
going to hit the 2 hour mark. So we
Yeah,
can
go
take
ahead.
one question where I think it's most come out, that somebody is working on a non-compiler domain and how they would want to switch to a compiler domain. I think that's I've seen a few people ask that question.
That's an interesting point. So yeah, I'll quickly answer this, and then I have one more thing to talk. So sorry. If you're in non-compiler domain, I would say definitely go through the videos that we did last year, like 10-part series. It is not like teaching you compilers, but it will give you some pointers to compilers, how to get started, how to build things, as well as some motivation, like why should I even move there? Just because people are talking about it, should I move it? So you will give some, I think that is very important. That will keep you motivated for a long time, and learning will follow. You can ping people on Discord or WhatsApp group or LinkedIn, Twitter, everywhere. And then I have found most compiler engineers to be very helpful, and so they can just answer your questions, or maybe ask them to give you 1 hour, like 1-2 hour session with them, and they can talk you through, like if you're stuck with something, and they can help you take the initial leap, and then maybe you can ramp up from there directly. And if you're looking for issues, LLVM project has, GCC also has, like not only LLVM, every compiler would have their whole ton of issues. Just one more thing I wanted to talk about was, like one thing people wonder, right? Like where are those like where can I hang out with compiler people? It's very important. Everything else you can find out if you know where those people are, where that herd is. So and this has been a problem because most companies would have 2-3 compiler engineers. Like only big companies will have like few dozen. Otherwise, it's hard to find one compiler engineer in every company. So how do they keep connected? And this is LLVM meetup is one of our initiative, because this problem is was more acute in India. So we want to connect with everyone. So LLVM meetup is one venue. We have WhatsApp group where there's people who are we only talk about compilers. And related very compiler adjacent things. There is a Reddit group, R compilers. If you want to talk, go there. LLVM has a Discord channel where there are very specific chat threads, so you can talk to them. There is LLVM in the LLVM Discord. There is an India channel also. So if you have, let's say you do not know anything about it, I will be very comfortable. You can just ask questions there. We'll help you there also. So this is super important before we ask any questions. So I would like to, I wanted to share this.